let's say we've deployed the contract, we have that contract on the chain, and now it's time to call its methods. So when you interact with a contract through call methods, the contract's storage remains unchanged. This means that no transaction needs to be sent. So the virtual machine of the blockchain system does not need to execute a specific transaction, because you're just basically reading a state value and there's nothing to be executed. So call methods simply read various storage variables of the deployed contract. And to create a script for this purpose, as always, you'll start with creating a file. We can name it like get.py or .js. Then you need to import the ABI, just like this line. Set up the Web3 provider, as always, like this line. And after that, you'll need to define the account from, including private key, which is required to sign the transaction. After that, create a contract instance using the web3.eth contract function and passing in the ABI address of the deployed contract, and use the contract instance to call the number function. So everything's basically the same as the previous example that we saw for deploying the contract. We just have a new function here to use this call method. This is how we use it. So we have the instance of the contract here, and we use the instance name, the functions, the name of the function, and then call. And this line, we just need to put each val here and then put .call after this, so we'll get the value, and it's our method call. The same functionality for JavaScript could be done using the syntax here. The only new thing we have that we need to mention in comparison to the previous part is this line. You'll write await, the name of the contract, that methods, that the name of the value that you wanna find out about it, that call. So this was the way we could use call methods in Python and JS. But there's another concept that is called send method, which is a little bit different. So in this part, we'll talk about send methods used to modify a contract's storage, which requires signing and sending a transaction. So there's actually something to get executed on the blockchain virtual machine. The purpose is to create a script to increment the incrementer, and you can create a file called increment.py or the JS, and then import the ABI and setting up the Web3 provider, define the account address, private key, public key, the contract address that you deployed, and the value to increment by. Next, you can create a contract instance, and you'll pass the ABI, the bytecode, just like the previous parts. And yeah, everything's basically the same. So let me just jump to the part that differs from the previous parts. Okay, here we have the ABI, the HTTP connection, these variables, our contract instance. This is the part that we kind of specify our transaction. So this is the part that differs a little bit from the previous parts. So we use our instance of the contract dot functions like the previous part, but this time we'll use a one of our contracts functions that are basically changing the state of the whole block, because changing a variable state's value is basically changing the state of the whole block, right? And yeah, we'll pass if the method that we're calling needs an argument, we'll pass an argument, and then we'll call build transaction with the appropriate values for the fields, and we'll have a transaction. And then, like the previous parts, we need to sign that transaction using a private key, and then send it using send raw transaction, and then wait for the receipt. And after printing out the hash, we'll see that everything worked properly. We have the same process going on for JavaScript. The only little difference we have here in comparison to the previous part is here. Nothing new, everything's like the previous parts. Yeah, just make sure that you are using this line to call our function, and the rest is the same. Okay, and this was how we kind of send method.